Section 4.3 is all about derivatives of inverse trig functions. So think of your sine inverse, cosine inverse, tangent inverse. So they start off talking about just inverse functions in general. So we do see this occasionally where you've got to find the derivative of inverses. So if we have the point, if f inverse of a equals b, then the derivative of f inverse of a equals 1 over f prime of b. And we use this very occasionally, but just kind of, I would put the if this part, then this part. Okay. Now, before you're going to freak out when I flip over, so just take a deep breath. So these are the 6 trig inverses. Now, the first thing I want you to notice, there's really just 3. Sine and cosine, these are the same. Secant, cosecant, these are the same. Tangent, cotangent, these are the same. It's just the cos are, you got it, negative. The cos are negative. So there's really just 3 to remember. And then you remember the cos are negative. What's kind of weird though, it's not the reciprocals, it's the cos. Cosine is the same as sine, but co is negative. Cosecant is the same as secant, but the cosecant is negative. Probably the one we see the most is tangent, luckily, because this is the easiest one to remember. So I'm doing this at home without my slate, so I'm just doing this using my cursor, so it might be a little sloppy. Okay, so if you look at sine inverse, the derivative of sine inverse is 1 over the square root of 1 minus u is just where we're taking sine inverse of. So that's x squared times, then we always chain on the derivative of x squared, which is 2x. And really, there's not always a lot you can do to simplify this. If we just go straight across, 1 times 2x is 2x all over the square root of 1 minus x squared is x to the 4th. All right. So a particle moves along the x-axis, so its position is tan inverse of the square root of t. If this is our position, remember they kind of interchange x and s. So what's the velocity at time equals 16? So first let's find v of t. So that's tan inverse 1 over 1 plus the square root of t squared is just t, times the derivative of the square root of t. All right, I'm going to go over here on the side for a sec. We know the square root of t is the same thing as t to the 1/2. If you take the derivative of t to the 1/2, that's 1/2 t to the negative 1/2, which is 1 over 2t to the positive 1/2, or 1 over 2 square roots of t. So one thing that's super duper helpful, we're going to get to the point where when you see the derivative of the square root of something, it's automatically 1 over 2 of that square root, whatever's under that square root. Now, if there's extra stuff, you just have to tack on the chain rule. But when I do the derivative of the square root of t, that's 1 over 2 square roots of t. Then we're going to find it when t is 16. So we want v of 16, which is 1 over 1 plus 16 times 1 over 2 times the square root of 16, which is 4. So we get 1 over 17 times 1 over 8. This is where my writing gets bad, which is just 1 over 136. Okay, so secant inverse, the derivative 1 over, now it says the absolute value, but what do we know about 5x to the fourth? This would always be positive, so I don't need the absolute value if it's already going to be positive. Sometimes they're going to try and trick you with that. All right, so we start off with that. And we're going to square what's ever inside here. 25, x to the fourth squared, power to a power, we multiply, minus 1, times the derivative of the inside, 20x to the third. Now this is all being multiplied, so this 5 can go into the 20 4 times. And if I have 3 x's on the top and 4 on the bottom, these 3 take away 3 of the 4 on the bottom. So I'm left with 1 times 4, so 4 over x times 25 x to the 8th minus 1. I'll be honest, these co-identities I don't usually mess up with a whole lot. You might want to include them in your notes if you end up taking your notes to college and want just a reference to them, that just to have them in your notes. All right, the last one, we want the equation for the tangent line, so we need a point and a slope. Let's start with the point. Think about, first of all, what does cotangent look like? Because it's important that we remember the restricted values. Cotangent looks like this, crosses at 0 at pi over 2. So where is it negative 1 at? Right here, there's an asymptote at pi. So that particular point is 3 pi over 4 negative 1. So if cotangent of, let's think of it this way, cotangent of 3 pi over 4 equals negative 1, then what do we do with inverses? Cotan inverse of negative 1 equals 3 pi over 4. All right, so this just means our coordinate point that we're using is negative 1, 3 pi over 4. All right, so now we find the slope, so we need the derivative. Y prime equals, since it's a it's a negative, negative 1 over 1 plus x squared. So we find our slope by substituting our x value of -1 in. -1 over 1 plus -1 squared is just 1. So our slope is -1/2. So when we do our equation, we have our y minus the y value equals our slope times x minus our x, which is -1. So we have x plus 1. And that is our inverses.